Part 4 of the Current Engineering Formula Checker add-in. The Formula Checker treats SI prefixes rigorously, but in some instances this could lead to uncomfortable output units. For instance, lengths of 1 kilometre are entered at cells A1 and A2. The formula at A4 is equal to A1 times A2. And in strict SI parlance, this creates an area of 1 million square meters, or 1 capital M2 as at C4. However, in common parlance, the product of 1 kilometer times 1 kilometer is 1 square kilometer. The formula checker therefore outputs a product of 1 kilometer times 1 kilometer as 1 kilometer squared, where the kilometer is italicized to indicate that this is a quasi-SI unit. But the quantity is treated in subsequent calculations as 1 megameter squared, or 1 million square meters. So if we enter a pressure of 1 Pascal at A5, followed by a formula at A7 equals 1 Pascal times 1 kilometer squared, the output is 1 meganewton. The formula checker treats millimeters in a similar way. So at C4, the product of 1 millimeter times 1 millimeter is equal to 1 millimeter squared, but the formula at D7, if we just refresh that, is output as 1 micronewton, i.e. 10 to the minus 6 newtons. It is sometimes convenient for the user to convert a prefix of an input unit to a different prefix on the output unit by inclusion of 1000 multiples in a formula. For instance, the diameter at cell G1 has dimensions units of millimeters. Entry of the formula at G3 equals pi times diameter squared divided by 4 gives the output in quasi-millimeter squared. This can be converted to meter squared by dividing by 10 to the 6th at G5, which gives an output in meters squared at H5. The transition from millimeters to millimeter squared to meter squared can be made in one step by the inclusion of the 10 to the 6th divisor into the formula as at G7. So we've entered 4 million on the bottom here, and it goes straight from millimeters at G1 as the input to meters squared as the output at G7. This works in the opposite direction. For instance, entry of 0.01 meters at J1 and J2 results in 7.9 times 10 to the minus 5 meters squared at J3, but multiplication by 10 to the 6th at J5 gives an output in quasi-millimeter squared at K5, and that can be done directly in the formula by including the 1 million multiplier directly into the equation at J7 to give again output in quasi-millimeter squared units at K7. Mass can be entered in either kilograms or tons, so at G16 we do Control Alt U, select M for mass, enter, and then T for tons, enter. We have a unit of tons entered here. This is actually treated as a kilogram, so at G18 we have divided the 1 ton by a distance of millimeters and an area of millimeters squared from G1 and G3, and this gives an output of gigatons per meter cubed. If we multiply that result by 10 to the 9th, then the output is correctly converted to tons per meter cube. If we had entered the mass in kilograms, Control Alt U, M for mass, enter, K for kilograms, then the formula that uses the same volume but the smaller mass, I6, then correctly calculates the density at 1.27 e to the minus 3 megatons per meter cubed. And if we multiply that by 10 to the 9th, then it gives us the units in kilograms per cubic meter. Native Excel contains a function convert, which converts from various units to various other units. This requires 3 parameters, which can be either text or cell references. So the first parameter is the value to be converted. The second one is a text string representing the unit that we want to convert from. And the third one is a text string representing the unit that we want to convert to. Excel gives us this drop-down list, which is not very user-friendly. We have to search through this until we find our required output unit, but Excel doesn't allow us to just select that. We have to memorize the form of the text string and enter that. We can enter a kilowatt if we want at the same time, and then close the formula, and the convert changes 1 horsepower to 0.75 kilowatts, and with the formula checker add-in running, it is output as a formatted special unit. It's not particularly user-friendly because you have to memorize the text string that you want to put into. It does work in the reverse direction, so we can put it in again, equals convert. This time we'll use the 0.75 as the first parameter. We'll use our kilowatts as the second parameter, and this time we're going to enter the text string HP, enter, and Excel converts it back to horsepower for us. The convert function is not very user-friendly. For instance, when we put in one of the parameters, we get the drop-down list, but it is full of ancient units that we're unlikely to want. Who, for instance, in the 21st century wants to convert from UK pints to US pints? The list is not alphabetical and it's not organized by disciplines, so it's actually very difficult to use. So the excellent formula checker has a special convert function which improves the efficiency of this process immeasurably. The Karen Engineering convert function allows the user to build up their own set of conversion factors. This is done under the Formula Checker tab. Set your own conversion factors, which produces a list of groups that we saw initially. We can select M for mechanical, and that brings up the previous list that we saw. We can select a velocity, for instance, which then brings up a input box that allows us to input our own conversion factors. So first of all, we enter the non-SI unit, for instance, MPH, and we can choose whatever symbol we like. The conversion factor is 0.47. We can specify, the user can specify whatever level of precision they like for that thing. And if we want to convert to an SI unit other than the base one, we would put in a prefix here. Clicking the Save button and Close enters that conversion factor into an XML file that's stored on the user's hard drive, which makes it available at any time in any spreadsheet, any time forward. In the present version, it's only loaded once we close the add-in and then reopen it. But now, if we do Control-Alt-K for convert, our new unit is presented in our own list of conversion factors. When we enter that, our non-SI unit is written, and if we enter a value here, the converted unit and the SI unit are also entered. Note that this is not actually a value, but is a formula that uses the conversion factor. So if we return to our input value and change 1 to 10, then the output is converted to 4.7 meters. As another example, we can create our own conversion factor from horsepower to kilowatts. Select the drop-down list for power, and we're going to use HP for our non-SI unit. If we wanted to convert to watts, then we would put in a conversion factor of 750, but if we want to convert straight to kilowatts, then the conversion factor would be 7.75, and adding K for kilo in the SI prefix, and then saving, closing. Unfortunately, we need to unload the add-in for it to be available. It writes the XML to the file, to the hard drive, reload the Excel formula checker add-in, and now if we put 1, Control Enter, Control Alt K, we find HP at the bottom of the list, and it gives us 0.75 kilowatts as the output. 100 horsepower is 75 kilowatts because the conversion factor is actually written into the formula. User-defined conversion factors can be managed or deleted, at least with the Manage Your Own Conversion Factors button. So if we return to the list, look up power, and then we can select that and remove the selected. Ask if we want to confirm. It says that that one's been removed from our list. Next time we open the formula checker, we'll find that unit, that conversion factor has been deleted. One further tool provided by the formula checker is a way to override the automatic calculation of a SI unit. In its normal mode, the formula checker add-in treats any constants in a formula as dimensionless. So for instance, if we entered 10, Control-Alt-U, Control-Alt-G, M, L for length, 10 meters, and we entered the formula equals pi times diameter squared divided by 4. We have the units output in meters squared because it treated the 4 as a dimensionless constant. This can be annoying sometimes if we want to, for instance, convert our meters into feet. If we put equals 10 divided by 0.3048, puts in the unit meters because we've simply entered a constant and we've started with a unit in meters. And it won't let me delete this because it's protected by the formula checker. But if we get rid of that altogether, then with keystrokes Control Alt O for override, it lets us put in a special formula, and we can say our result here is equal to that value divided by 0.3048, enter, and I can now enter whatever I like in this box here. This cell remains overridden, so if I want to convert to yards, I can revise the formula to a different conversion factor, and I can still write any text I like into E7. To return the cell D7 to its normal treatment by the formula checker, I select the cell and from the formula checker tab choose remove formula override. Next time I return to this and enter a formula equals this divided by 0.3048. The formula checker writes meters again and treats the constant as dimensionless.